All right, so here's the practice test key for chapter 4. Let's see. So, number 1, identify any congruent figures in the coordinate plane. So on this one here, kind of look at the answers there because it's kind of a drag and drop. All right, so if we look at it, we have some triangles, we have some quadrilaterals here, and we have a translation, and look at what we have: 9 units left, 12 units down, 12 units left, 9 units down. We have a reflection on the y-axis and a rotation. So let's kind of look and see which ones. So kind of look at ones and see if they're about the same size. Well, if you look, A, B, C, D, and W, X, Y, Z are the same size. So let's just choose a point. That's always my suggestion, is choose one point and see what happens. So if I choose that point right there, okay, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we look there at 9, I am at the edge of the other one here. So the left edge, just like I started with the left edge there. So we just went 9 left. And then let's see if we can go 9 down, 12 down, I think is what one of our choices was. Yeah, 12 units down. So if we can get this to go 12 units down, then we'll be good. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And notice it does go to that one right there. So we would be able to drag and drop, ladies and gentlemen. I'll have to write it here for you. So we would be able to say that quadrilateral ABCD is figure 1. The second one is quadrilateral, because again, we're looking at the congruent ones, W, X, Y, Z. And what did we just did? We just did a translation. We did 9 left, and then we went 12 down. All right. So I guess I should have put the 12 down there. All right. So we know on that one that works. So with the other one, if you notice, we didn't have a dilation there. So that's why I didn't even consider the bigger quadrilateral. So now let's look at the triangles. So if we look at the triangles, okay, well, this one here has a 2 by 2 and a 2 by 2. This one here is 3 by 2. So I'm going to look at EFG and JHK. All right. So as I'm looking at those, I'm going to notice that here we have a right angle, and here would be our right angle here. So let's go ahead and concentrate on what that point is there. So if I look at that point, I'm going to go over 5 and I'm going to go up 2. So my point for F is 5 and 2. All right. So now if we look, the corresponding right angle on the other one is J. And let's see what that one is. It would be going 5, negative 5, and down negative 2. So we'll have negative 5 and negative 2 for this one here. And if we look at that, what's that going to be? Well, we know it's going to be a rotation. And again, if you look at your notes, you'll see that it would be a rotation of 180 degrees, because the rule was XY goes to negative X, negative Y. And that's what you have here. 5 and 2 went to negative 5 and negative 2. So we would have a rotation 180 degrees. So to finish that one up there, we would have triangle EFG. And again, it is congruent to triangle HJK. And so we just said that was a rotation of 180 degrees. And again, it says at the origin. I'm not going to write all of that down. because again, you would be dragging and dropping. Okay. Number 2 is when using the vector. So we're going to use the vector for our one that they have here. So remember, all a vector does is it tells us what direction we're going to go in the x direction and what direction we're going to go in the y direction. So it's telling us there's our x and y. We're going to take our points and we're going to go -1. So we're going to go left 1, and then we're going to go up 7. So I'm going to go left 1, and I'm going to go up 1, 2, 3, 4, 5, 6, 7. All right, so and that's one of our points. We're going to take this point here. I'm going to go over 1 negative, so it's left, up 7. And that one will be there. And then this last one here, we're going to go over 1 and up 7. And that one would be right there. So, and now we're just going to connect our points. And with you guys, it'll be a little better. But there's my one right there. Okay. On the next one, number 3, quadrilateral MP and Q has vertices of M is 0 and 6, N is 4 and 4, P is 6 and -1, and Q is 2 and 0. So they want us to look at it after the translation of taking our x coordinate and our y coordinate, and we're going to add 2 to the x, and we're going to subtract 1 from the y. So if we do that for our M prime, our x value was a 0, and then we're going to say we're going to add 2 to that, and our y value was 6. And we're going to subtract 1 for that. So our value for M prime will now be 2 and 5. All right. Now the other ones, let's just do it in our heads. So 4 plus 2 is going to be 6. And 4 minus 1 is going to be 3. For our P, we're going to have 6 plus 2, which is 8. So our P prime is 8. And we're going to have -1 minus 1. So our y value for P prime is going to be -2. And then for Q, again, one more time, 2 plus 2 is 4. And 0 minus 1 is -1. All right, number 4, the coordinates of the vertices of quadrilateral ABCD are 2 and 3, 6 and -2, C is 10 and -1, and D is 11 and 6. So identify the coordinates of the vertices after the composition. So remember, a composition, we're going to do a couple of things. So we have to do this one first. So when we do this one first, this will be our A prime. And again, we're going to just do kind of what we just did with the last problem. So I'm just going to go ahead and write it out for you. We're going to say our x and y here. So 2 plus 8 is 10. And 3 minus 4 will give us -1. If we do the same thing for the other ones, we'll get B, we'll get 14 and -6. For C, our C prime will now give us 18 and -5. And then our D prime will give us 19 and 2. All right. On this one here, they don't give us any choices for those. So that means that we have to do the next one. So our next translation, remember, on this one here, we use the A prime, which we just had above. So we're going to use this as our x and our y for our second translation. So our A double prime, if I do that, I'm going to have 10 minus 1, which will give us 9. Now I'll have -1 plus 1, which will give us 0. So on this one here, you'll drag and drop 9 and 0. So 9 and 0 would go right here. All right, similarly, we would do the same thing for B. So if we do it for B, our B prime will now be 13 and negative 5. Our C double prime will be 17 and negative 4. And our D double prime will be 18 and 3. And again, you would drag and drop those here. All right, so number 5, determine the coordinates of the vertices of the image of triangle ABC after a reflection in the line y is equal to x. So on that one there, it is telling us our rule for a reflection on y is equal to negative x. The rule is our xy will now go to negative y, negative x. So that tells us we're going to take our points and we're going to flip them. And if they're positive, they can become negative. If they're negative, they become positive. So on A, our A prime will become 4 and 3. And we are going to negate both of those. On B prime, we'll have 2. It'll be negative 2. We'll have 3. That'll become negative 3. For C, we'll get negative 2. But for our y value, we'll get negative 1 or a positive 1. Number 6, let's graph triangle ABC and with vertices A at 6 and 5, B 9 and 7, C 8 and 1, and its image after a 90-degree rotation about the origin. So we are going to graph our A, B, and C. So we're going to have, let's see here, 6 and 5. So I'm going to go over 6 and up 5. That will become our A. Our B is at 9 and 7, so over 9, up 7. And our C, we're going to go over 8 and up 1. So there's our C. Let's see here. Yeah, but I don't know how to pause it, so. All right, thanks. All right, and we're going to attach those. So somebody just came in and said hi, and I can't see the pause button this time. Sometimes I see it, sometimes I don't. So there's our original one. And now they want us to do a rotation of 90 degrees. So remember, a rotation for 90 degrees. Again, I'll have these up for you, ladies and gentlemen. Actually, I have them on the board right now. But it'll tell us that our XY, when it's a 90 degrees rotation, we're going to take our Y and it's going to become negative, and we're going to exchange our X. So we're flipping it over. So knowing that, our A, which we just had, was 6 and 5. Okay. Again, our Y, we're going to make negative, and our X stays the same. And we flipped it. For B, we have 9 and 7. So we're going to say our B prime, I should have put my A prime there. Our B prime will be negative 7 and positive 9. And our C, which was 8 and 1. Again, we're going to flip it. So our 1 becomes our X, and we're going to make it negative, and our 8 will stay the same. So let's go ahead and go back up here and plot those ones. So I'm going to say it's negative 5 and 6. So I'm going to go over negative 5 and up 6. And I'm going to go over -7 and up 9. And I'm going to go over -1 and up 8. So here's my C prime, here was my A prime. But when you're doing this on your big ideas, you won't have to put the letters there. You just have to make sure that they're in the right place. Okay. And I will be kind of looking at that too when I give you partial credit. All right, number 7 says the distance between line A and line B is 12 millimeters. The pre-image is reflected in line B, then in line A. Here's the key. So they just told us it's reflected. So we reflected from P to P prime. And then we went from P prime, we reflected that to P double prime. That took two transformations, not just a single one, and they're asking us for a single transformation. So I want you to remember that they said the distance here is 12 millimeters. All right, and so we know if we take one, if you look at P there, all right, here's your P, and if we just look and we transferred that, it would be the same as this one here. So it's a single translation. So I just said translation. So it's a single translation. And remember, what you do is when they say it's a single one, you double the 12 millimeters. So we're going to double that. So that means we're going to go 24 millimeters. And which way did I go, people? I went left. So make sure you pay attention to that, because if you do put right, which is one of your choices there, it would mark it wrong. Okay, so be careful with that. Number 8, it says find the scale factor of the dilation and tell whether the dilation is a reduction or an enlargement. So remember, we can say that our scale factor, which is K, we can write it as CP prime over CP. All right, so our CP prime is this one right here, so that's going to be 10. And then our C to P is going to be the distance of 20. So we can take that and we'll have matching zeros. We can get rid of that. It reduces to 1/2. So our K is going to be 1/2 on this one here. And remember, if it 1/2, and it is a small fraction and it is between 0 and 1, if our fraction is between 0 and 1, that will give us a reduction. If it's greater than 1, it would make it an enlargement. Okay, number 9, quadrilateral WXYZ has vertices -4 and 8, and X is -4 and 0, Y is -12 and 4, and Z is -8 and 16. Identify the coordinates of the vertices of each figure after the similarity transformation. So just like the previous one we did, we have to do this one first. Once we have that one done, then we would do this one second, based on the first one. So on the first one, it's telling us we're going to add 4 to our X value, and we're going to subtract 4 from our Y value. So on our first one here, again, I'll just do one of them, and then I'll show you. I'll just write the other ones down so I don't waste a lot of your time. So we're going to have W, and again, W prime. So -4 plus 4 is going to give us 0, and 8 minus 4 is going to give us 4. All right, our x1 same thing. -4 plus 4 will give us 0, and 0 minus 4 will give us -4. For y prime, we'll get -8 and 0. And for z prime, if you work it out, you'll get -4 and 12. So those ones, you're going to drag each and every one of those. So 0 and -4, 0 and 4. When I say -8 and 0, and -4 and 12. And remember, the second one is based on the number 1 there. So we're going to look at it, and we have to look at these ones here. And with this one here, we made it so it's nice. So if I take 1/4 of 0, so I'm going to take 0 divided by 4, that's going to give us 0. And when I take 1/4 of 4, so 4 divided by 4 will give me 1. And then similarly for x double prime, I'll get 0 and -1. For y double prime, I'll get -2 and 0. And this, for the last one, finally, -4 divided by 4 will give me -1. And 12 divided by 4 will give me 3. So those would be the ones you would drag and drop to this one here. Sorry, I just didn't mean to do that one. All right, and let's see. I say 0 and -1, 0 and 1, and what was my last one? 1 and -3, and -2, 0. There we go. All right. Again, on this one, this is kind of just like the one we just did up here on number 7. All right. But this time we're dealing with the angle there. All right. Now here is the key. As long as it says it's going to take us from A to A double prime, and we have our 2 intersecting lines, but it's telling us all we have to do is we have to take that degrees, and we're going to multiply it. So 2 times 45, that will give us 90 degrees. Number 11, find the scale factor of the dilation and tell whether the dilation is a reduction or an enlargement. So on this one here, again, just remember K is equal to CP prime over CP. All right. So on this one here, if you look, CP prime is 18 and CP is 4. On this one here, you would have to reduce it. Again, remember what I said. If you don't reduce it, big idea is they'll mark it wrong. So you can do it as 9.2, or I'm pretty sure if you just divided 18 by 4 and put in 4.5, that would probably go ahead and give it to you. And remember, our K in this case is greater than 1, so we're going to have an enlargement. So our factoring is, again, 9/2. Reduce the fraction if you can. I'm pretty sure it'll give you it as 4.5. If it was one where you had a repeating decimal, I don't think it'd like it as much, but on this one here, it does terminate at 4.5. And again, it's greater than 1, so you know you have an enlargement. All right, graph DEF with vertices 1, 1. E is 3 and 1, F is 1 and -3. Sorry, E should be 3 and -1, not 3 and 1. So E is 3 and -1, and F is 1 and -3. And an image after the dilation centered at the origin with a scale factor of 4. So let's go ahead and just do our first one. So 1 and 1. There's our D. E is 3 and -1. So there's E, and our F is at 1 and -3. Connect those dots. And then remember what we just talked about on the dilation. The rule for a dilation is that x times y goes to, in this case, our k times x and our k times y. In this case, let's just go ahead and I'll tell you the first one right here. D would be 4 times 1 is 4, and 4 times 1 is 4, so our D prime would be 4, 4. Similarly, we would have our E prime, would give us, excuse me, 12 and negative 4. And our F prime would give us 4 and negative 8. Because again, I just multiplied everything by 4. So on that one there, what did I say, 4 and 4. So I'm going to go 4 and up 4. Our E prime is 12, so I'm going to over 12, and I'm going to go down negative 4. And our F prime is 4 and negative 8, so I'm going to go to 4 and down to negative 8. And as you can see, it did enlarge it. And here's our D prime, our E prime, and our F prime. Okay. All right. Well, we're getting there, people. All right. So, again, all you have to worry about is that it tells you what to do. All right. So on this one right here, our factor, so the graph shows quadrilateral A, B, C, D with vertices A at negative 8 and 0, B negative 4 and 8, C 0, negative 4, and D negative 8, negative 8. And on this one here, we need a scale factor of negative 1/4. If you still put this all in, ladies and gentlemen, it will do everything you need to know. First of all, since it's less than 1 or k is less than 1, we know it's going to make it smaller. And on this case here, that negative means it's going to be a rotation. So it's going to actually do all of that for us. So we are going to go ahead and do this. So again, let me see here. Why don't I go over here? So our A prime, again, if I take negative 1/4, so I'm going to take 8 divided by 4, which is 2, but I have a negative and a negative, so that'll give me 2 and 0. Again, B would give us 1 and negative 2. B prime, I'm sorry. I said 1 and negative 2. C would give us, C prime would give us 0 and 1. And D prime would give us 2 and 2. So let's go ahead and do all those. So A would be 2 and 0. B would be 1 and negative 2. C is 0 and 1, and D is 2 and 2. And again, connect our dots. A prime, B prime, C prime, and D prime. All right. Again, when you're doing it online, it'll look a little nicer. I'm just trying to get this so it's not a big, huge, long video for you. Number 4, you are using a magnifying glass. Remember, when you make a magnifying glass, it makes stuff bigger. So determine the length of the termite seen through the magnifying glass. All right. And it's telling us we're doing it 6 times. So what you should notice, ladies and gentlemen, is that we're going to take our K. I'll go ahead and write this down, which is our image over our pre-image. Or it's like our CP prime over CP. All right. And we're going to say, in this case, it would be 6 over 1. is equal to x, which is our image, and our pre-image, its length is 9.5. If you look at it, we can again take our cross products. I know a lot of you said, oh, hey, why don't I just multiply it by 6? Well, isn't that what I'm doing? 6 times 9.5 is equal to 1x. So x is equal to 6 times 9.5, which will give you 57 millimeters. That would be 57 there. All right, our last two are our review questions that we're having little problems with. So the first one, write an equation of the line that is passing through the point 5 and 1 and is perpendicular to the line 5x plus 3y is equal to 15. First thing you have to do is get that into slope-intercept form. So we're going to take our 3y, we're going to take our 5x, and we're going to move it over to the other side so it becomes negative, and then we're going to have plus 15. I'm going to divide each and every term by 3. So I get y by itself, which is what I wanted, is equal to negative 5/3 x plus 5. The plus 5 isn't what's going to matter to us. What's going to matter to us is the negative 5/3. Remember, if I'm looking at a line that is perpendicular to it, that means I'm going to take my negative 5/3, so my perpendicular slope, I'm going to take my negative 5/3, I'm going to flip it, so that will give us negative 3/5, but then I'm going to take the opposite sign of the negative, so it's going to become 3/5. So now since I have 3/5, we know that my new equation is going to be y is equal to 3/5 x plus b. So we at least know our slope is 3/5. Now we just have to find out what our b is. To find out what our b is, that's why they gave us this point. We're going to plug in that point. So we're going to have 1 is equal to 3/5, because again, that's our x, that's our y. We're going to have our 5 here plus b. All right, 3 times 5 is 15 divided by 5. Or you can just cross those out because you have one on the top and one on the bottom. So we'll get that 1 is equal to 3 plus b. To get b by itself, you're going to subtract 3 on both sides. We'll get that b is equal to negative 2. So the equation of your line is y is equal to 3/5 x plus, and then you're going to put a negative 2 there. And our last one, it says parallel. So on parallel, we know we have the same slope. So again, we're going to do the same thing here. Now, watch and be careful. We might have already, on the other one, put it in slope-intercept form already for you. So if not, then we have to get y by itself, and has to have no number in front of it. So we're going to have negative 5x plus 12, and then I'm going to divide each one by 2. So that would give us our y is equal to negative 5/2 x plus 6. So your equation, all right, so it's parallel. So our parallel lines have the same slope. So it's going to have a slope of negative 5/2 x. Well, negative 5/2 in front of the x. Now we just have to write and figure out what our b is going to be. So again, our parallel line is y is equal to negative 5/2 x plus b. Let's plug in this point here. So y is equal to 3. We have negative 5/2 times a negative 10 here plus b. Negative 10 divided by 2 would give us negative 5. So negative 5 times negative 5 would give us 25. So we'd have 3 is equal to 25 plus b. Again, to get b by itself, we'll subtract 25 on each side. That will give us that b is equal to negative 22. So the equation of your line that is parallel will be negative 5/2x plus a negative 22. All right. Again, the test is similar, ladies and gentlemen. Make a good cheat sheet. Thank you.